Hello, and welcome to the Properties of Exponents, starring me, Agent Brandolino. I am a distant relative of Mrs. Brandolino, and she asked me to come help her out to teach this lesson. So the first thing we're going to talk about is, what is a power? I know I'm very powerful, but what is a power? A power is a number that has a base and an exponent. So, for example, if I have the number of 4 to the third power, this is saying the 4 is the base. It is the bottom number. And the 3 is the exponent. It is the little small number on the top. Together, with their forces combined, they create a power. The one thing you need to know about powers is any number to the 0 power equals 1. If I have a little old 2 to the 0 power, that equals 1. If I have 734 to the 0 power, that equals 1. If I have a negative 64 to the 0 power, that equals 1. If I have everyone's favorite, a fraction, 1/2 to the 0 power, it equals 1. 1. There are 3 properties of exponents that we are going to be talking about today. We're going to talk about multiplying a power with the same base, dividing a power with the same base, and then a power of a power. Here are the directions that you're going to see throughout this lesson. You are going to have to express each answer in exponential, there it is, form, and express the numerical answer. Now, what does that mean? If you are expressing, that's just a big fancy agent word for write. So write each answer in exponential form. By exponential, I'm saying, for example, 3 to the second is exponential. It has an exponent. And then express or write your answer numerically or as a number. So, for example, 3 to the second would be 9. So here's our first one. If you have 2 to the third times 2 to the fourth, that is saying 2 times 2 times 2. Now you have this times 2 times 2 times 2 times 2. You have the base of 2 3 times, and then the base of 2 4 times. Now I'm going to show you 2 other ways that you can write this. You can write it 2 times 2 times 2 times 2 times 2 times 2 times 2. You could write it 2 times 2 times 2 times 2 times 2 times 2 times 2. Both of these ways are an accurate way to show this same problem. Now, with this first one, the reason why I would like you to kind of stay away from that is because a little later in the year, we are going to be using x's a lot as variables, and you might get your variable and your multiplication sign mixed up. You may use parentheses. Most kids right now are not really friends with parentheses yet, but you soon will be. So if you want to start using parentheses, go ahead. A lot of us use the dot because that's the quickest way to show multiplication. Alright, so we have to show this right here, this whole thing, as an exponential answer. So I'm going to write my base of 2, and then I'm going to count. 1, 2, 3, 4, 5, 6, 7. There are 7 2's, and that is your exponential answer. You then can use a calculator to do 2 times 2 times 2 times 2 times 2 times 2 times 2, and your answer would be 128. Here's another one. Again, you can write this using parentheses, the little dot, or the multiplication sign. The 3 to the second is saying I have 3 times 3. There is 2 3's. Because they're parentheses, this is the same as multiplying. And now I have 3 more 3's. 1, 2, 3 more 3's. I need to write this as an exponential answer. My base is 3. 1, 2, 3, 4, 5. I have 5 of them. I'm then going to do 3 times 3 times 3 times 3 times 3 and get 243. Your exponential answer and your numerical answer. Now, there is a shortcut where you don't have to write out all those 3's. What if you had, I don't know, 3 to the 20th and 3 to the 50th? That would be so many 3's. Now, do you notice up here the bases are the same? Look at the exponents. What did we do to get that answer? The bases are the same. Look at the exponents. What did we do to get that answer? That's right. You have to, if you are multiplying the powers with the same base, that's the key. The base has to be the same. You will keep that base and then add the exponents. Let's try one. First of all, it's the same directions. We're going to make sure our bases are the same. They are. So we just have to add the exponents. I'm going to write the base of 5. I'm going to add my exponents. 3 plus, there is no exponent here. How many 5's do you see? You see 1? All right, so that means it is 5 to the first power. Now we can finish our problem. 5, 3 plus 1 is 4. There is your exponential answer. If I plug that in, you get 625 for your numerical answer. Next, we're going to talk about division. So in multiplication, you add. Division, let's figure it out. You have 6 times 6 times 6 times 6 times 6. There are 5 6's. Divided by 6 times 6 times 6. Notice the bases are the same. That's when it works. Okay? I'm going to show you off here this side. If I had 6 divided by 6, most of us know that we can cancel these and create a 1. Same thing here. If I go like this, I have 6 divided by 6 is a 1. 6 divided by 6 is a 1. 6 divided by 6 is a 1. Anything multiplying by 1 is the same answer. So we don't really have to worry about that. Now, do we? No. All right. On the top, you have how many 6's? There are 2 of them. 6 squared. And on the bottom, we just have 1's. And if you're multiplying and dividing by 1, it stays the same. So I'm not even going to worry about those 1's. And what is 6 times 6? 36. Numerical and exponential answer. Can you figure out the shortcut for dividing with the same base? Look at your exponents, and how did we get that answer? If you said subtraction, you are correct. To divide the powers with the same base, keep the base and subtract the exponents. Okay? Let's try one. Here we go. If you have 8 to the 12th divided by 8 to the 9th, I don't want to have to write it all out. It would take so long. So instead, because it's division, I'm going to write the base and I'm going to subtract the exponents. Keep the base. 12 minus 9 is 3. That is so much faster. And then I can do 8 to the 3rd is 512. Exponential, numerical answer. The last type we're going to talk about are the power to powers. Okay? So for a power to power, you have 2 to the 3rd to the 2nd. So what this is saying is I'm taking this whole thing twice. So I'm taking this and I'm doing it again. I'm taking it twice. And then 2 to the 3rd is looking like this. This is multiplying. 2 to the 3rd looks like this. So now I can find my exponential answer. I have my base of 2, 1, 2, 3, 4, 5, 6, which if we started up here, we knew because the bases were the same and we're multiplying that we just add the exponents. But there's an even shorter cut. Look at your exponents. Can you get to there without doing all of this work? I think you can. In order to do that, you're going to multiply. So you need to multiply when you have a power to a power, keep the base, and multiply the exponents. Let's try it. All right, so you have 3 to the second to the second. So you're going to keep the base, and then you are going to multiply the exponents, which is 2 times 2 is 4. There's your exponential answer. 3 to the 4th is 81. There's your numerical answer. Ah, watch out, hands up. Look at this one. This is going crazy. All right, same thing. You are going to use everything you've used to solve this one problem, and you can do it. Let's try. Okay, first we're going to notice all of the bases are the same. Okay, let's start with the top. The top is multiplying. So when we multiply, we're going to keep the base and add the exponents. Correct. Let's look at the bottom. We have a power to a power. If you have a power to a power, you keep the base and multiply the exponents. So now let's do keep the base. 3 plus 4 is 7. Keep the base. 3 times 2 is 6. The last thing you need to do is the division. The bases are the same, so you subtract. So the next thing you have is base is the same, 7 minus 6. 4 to the first power equals 4. That's not so scary now, is it? Here's your exponential answer. Here is your numerical answer. Have a great day.